In this lesson, we look at information presented on IFR charts. This includes minimum IFR altitudes, chart symbology, routing, and airport, airspace, and nav aid information. The sources used for this lesson are the Air Force Manual 11-202 Vol 3, the FAA-produced Aeronautical Information Manual, Instrument Flying Handbook, and Instrument Procedures Handbook. These FAA handbooks are available for free download at faa.gov, as well as loaded into your for-flight documents. There are two types of IFR charts. Low-altitude charts are used for navigation below 18,000 feet MSL. High-altitude charts are used when flying in Class A airspace at and above 18,000 feet. These charts contain a good deal of information. ForeFlight contains a Legends folder in the event you are unsure the meaning of any of the printed information found on aeronautical charts. We'll start by talking about published routing. Routes are based on either ground-based nav aids or GPS navigation. VHF routes are depicted in black and found between two VORs. Below 18,000 feet, these are called Victor Airways. Victor Airways begin at 1,200 feet AGL and are categorized as Class E airspace. They can be flown under IFR or VFR, which is why they are also depicted on VFR sectional charts. Here, Victor 438 connects Barrow and Dead Horse VORs in northern Alaska. The total airway length is 178 nautical miles. Between Barrow and Dead Horse, there are 6 waypoints. The distance of each segment is depicted. For example, the distance between Sedgey and Okike is 34 nautical miles. The distance between Barrow VOR and Okike is 50 nautical miles. The route from Barrow and Dead Horse happens to be a joint Victor RNAV airway. GPS-based airways are blue. Below 18,000 feet, these are called T routes or Tango routes. Airways colored brown depict low and medium frequency routes and are based on NDBs. With the phasing out of NDBs, these airways are mostly found in Alaska. Here, Airway Gulf 16 connects the Browerville and Putt River NDBs. At and above 18,000 feet, VOR-based airways are called jet routes. Here, J507 runs between Barrow and Dead Horse. Like on low charts, GPS routes are depicted in blue. These are called Q routes. Often, routes start and end at ground-based nav aids and contain 5-letter waypoints. Some of these nav aids and waypoints are shaded in, while most are not. Shaded nav aids and waypoints are called compulsory reporting points, and unfilled points are non-compulsory reporting points. Federal regulations require pilots to maintain a listening watch on the appropriate frequency and furnish position reports passing certain reporting points. The designated compulsory reporting point symbol is a solid triangle, and the on-request reporting point symbol is the open triangle. Reports passing an on-request reporting point are only necessary when requested by ATC. When informed by ATC that their aircraft are in radar contact, pilots should discontinue position reports over designated reporting points. If radar contact is lost, pilots then must report when passing over solid-colored nav aids and waypoints. When navigating using ground-based nav aids, the navigation source used changes at the halfway point unless otherwise depicted. Here, the total distance between Grand Junction VOR and Carbon VOR is 97 miles. If you were to fly from Grand Junction to Carbon, you would normally change the nav frequencies at the halfway mark of 48.5 miles. However, a changeover point is published for this route. 112.4 should be used for navigation within 72 miles of Grand Junction VOR, and 115.5 used when within 25 miles of Carbon VOR. Now we'll talk about minimum IFR altitudes. Your filed cruise altitude is determined by you, the pilot. There are many considerations to picking your en route altitude, to include distance to the destination, fuel burn, terrain, special use airspace avoidance, and weather conditions such as cloud coverage, winds aloft, turbulence, and icing avoidance. This lesson does not go into how to pick your cruise altitude. Rather, we look at minimum altitudes printed on IFR charts to help you determine the lowest altitude you should fly while VFR. Minimum IFR altitudes printed on charts are based on terrain clearance and ground-based nav aid signal coverage. These altitudes do not assure ATC radar coverage or communications are available. Therefore, when weather and aircraft capability permits, you should fly at an altitude well above these minimum altitudes found on the chart. The first altitude we'll talk about is the MEA. MEAs are the lowest published altitude between radio fixes, which assures acceptable navigational signal coverage and meets obstacle clearance requirements between those fixes. There are two MEAs on the Victor 8 airway between Grand Junction VOR and Rifle VOR. Between Grand Junction VOR and Squat Waypoint, the MEA is 10,500 feet. Between Rifle VOR and Squat, the MEA is 13,200 feet. An MEA change on an airway is indicated by a sideways T at an intersection. Notice on Victor 8, Squat is enclosed with the sideways T's, whereas Paddock and Horst are not. A mocha, not to be confused with the tasty drink, is the lowest published altitude in effect between radio fixes on a VOR airway. Like an MEA, a mocha meets obstacle clearance requirements for the entire route segment. Unlike the MEA, however, the mocha only assures acceptable navigational signal coverage within 22 nautical miles of a VOR. Mochas are the asterisk altitudes found under some MEAs. On Victor 8, the mocha between Grand Junction VOR and Squat is 9,600 feet. Between Squat and Rifle VOR, there is no mocha. An Aroka is similar to the maximum elevation figure found on VFR sectional charts. It is an off-route altitude which provides obstruction clearance with a 1,000-foot buffer in non-mountainous terrain areas and a 2,000-foot buffer in designated mountainous areas within the United States. This altitude may not provide signal coverage for ground-based navigational aids, air traffic control radar, or communications coverage. Each lat-long quadrant contains an Aroka as seen circled here. MRAs depict the lowest altitude at which an intersection can be determined. PACES on Victor 134 is an intersection waypoint. If GPS or DME were not available, PACES could still be identified by cross-tuning the Grand Junction and Meeker VORs. As long as you are at or above 13,000 feet and on the Grand Junction 060 radial, you'd know you're at PACES when crossing the Meeker 182 radial. This method of identifying PACES requires having two VOR receivers in your aircraft. An MCA is the lowest altitude at certain fixes which an aircraft must cross when proceeding in the direction of a higher MEA. On Victor 8, Squat contains a minimum crossing altitude of 12,000 feet when flying northeast from Grand Junction VOR to Rifle VOR. As covered earlier, the MEA changes on Victor 8 from 10,500 feet to 13,200 feet. Due to increased airspeeds at 10,000 feet MSL and above, the published MEA may not be sufficient for obstacle clearance when a turn is required over a fix, nav aid, or waypoint. In these instances, an expanded area in the vicinity of the turn point is examined to determine whether the published MEA is sufficient for obstacle clearance. In some locations, normally mountainous, terrain or obstacles may necessitate a higher minimum altitude while conducting the turning maneuver. For example, slalom has an MTA of 12,900 feet if flying northeast on Victor 134 and then turning northwest to intercept Victor 220. A lot of basic information about an airport can be found on IFR charts. Here you can see San Antonio and Austin, Texas shaded in blue. Class Bravo and Charlie airports are both shaded this way. Looking at San Antonio International, we see the airport is Class Charlie airspace. The field elevation is 809 feet, the airfield has lighting for night operations, the longest runway is 8,500 feet, and their ATIS is broadcast on 118.9. Just to the east of San Antonio is Randolph Air Force Base. The blue text indicates the airfield has published approach procedures and/or radar approach minimums published in at least the high altitude DoD flight information publications. It is a Class Delta airport, but when the tower is closed, it reverts to Class E. Just northeast of Randolph is New Braunfels, also a Class D airport. Since the text is in green, it has instrument approaches, but they are not published in high-altitude DoD flip. Airports in brown text do not have instrument approach procedures. Airspace controlling agencies, frequencies, and boundaries are also found on IFR charts. The postage stamps indicate the name of the ATC center and the frequency they are likely to be using in that area. Here is a boundary separating Denver Center and Salt Lake Center airspace. To wrap up this lesson, we'll look at a few random pieces of information located on IFR charts. Waypoints Max and Loma can be identified by cross-tuning the Grand Junction VOR and Grand Junction localizer to runway 11. On the localizer frequency of 110.3, Max is located 25 nautical miles from the localizer antenna, and the inbound course is 112 degrees. Grand Junction is a VOR with DME, as depicted by the box around the hexagon. For aircraft with distance measuring equipment separate from the VOR or localizer receiver, the DME channel is listed, and that is 71. Grand Junction ILS DME channel is 40. Both of these nav aids can be put into the GPS as well. Grand Junction VOR is Juliet November Charlie, and the localizer antenna is India Golf Juliet Tango. Localizer identifiers always begin with the letter I. As with DME channels, TACANs and Vortax list their TACAN channel next to the nav aid's 3-letter identifier. On the topic of nav aids, a number of VORs throughout the United States include flight service station information. As covered in the VFR cross-country planning videos, flight service stations are a bit like Air Force base operations shops. They can file, activate, and close flight plans, provide weather briefings and current area and terminal conditions, as well as advise pilots of NOTAMs and other advisories should the pilot request them. To contact a flight service station near Carbon VOR, you can contact the Cedar City Flight Service Station on 122.2, 122.5, or the countrywide UHF frequency of 255.4. There are many service stations located throughout the United States with different facility names and frequencies, so when you contact them, include their name and frequency you are transmitting on. For example, Cedar City Radio, Texan 13 on 122.2. If no answer, climb higher if able for better radio reception or try a different frequency. Also located throughout the IFR chart are published holding patterns in the event ATC needs to hold you for traffic delays, or you need to hold waiting for weather conditions to improve at your destination airport. For example, if holding is required, it could be done over point Lolo. ATC would simply say hold southwest of Lolo as published, and then they would provide you and expect further clearance time. That covers the majority of the information found on IFR charts. For anything that wasn't covered, consult the chart legend and publications listed at the beginning of this lesson.